Alright folks, in this video we're going to look at if we've got a recurring decimal such as 0.23 recurring and changing that into a fraction. This is a little bit tricky, it involves a tiny bit of algebra, but if you bear with me then hopefully you'll understand how to do this. Now let's start with a recurring decimal, but it's only one digit in the pattern just to get the method down. Let's say 0.2 recurring. Remember that means 0.2 2, and there is infinity twos, and we're going to change this into a fraction. Alright, so what we do is we write x equals our decimal that we want to convert to a fraction, and then we are going to find either 10x, 100x, 1000x, 10,000x, 100,000x, a million x. It depends on the decimal. We want the number of zeros after this 1. The number of zeros, we want as many zeros there as there is digits in the pattern that are recurring. So in this case, since it's just 2 recurring, we just want 1 0, so 10x. Now at this step, if we had the first example, 0.23 recurring, then we would want to find 100x because there's 2 zeros, because there's 2 digits in the pattern. And we'll see why shortly as well. So for now, let's say 0.2 recurring, so we just want to find 10x. So first step, x equals the number that we want to find as a fraction. Next step, we find 10x or 100x or 1000x, depending on how many digits there is in the pattern that's recurring. Alright, so 10x, well, if we were to times this by 10, let's visualize this number a little bit. Let's say 0.22222, and we've got infinity twos after it. If that's one of them, 10 of them would just be moving the decimal point one place to the right. So that would be 2.222222. So 10x is 2.2 recurring. It's still recurring, there's still infinity twos afterwards, and then after that we do 10x take away x. Now 10x take away x, that's 10x take away 1x. If we take 1x away from 10x, we get 9x, and we can find what 9x is as a decimal by doing this 10x, not 2.2 recurring, take away 1x, 0.2 recurring. So here we've done 10x take away 1x, so we're gonna do 2.2 recurring take away 0.2 recurring, and that will give us 9x. So 2.2 recurring, let's visualize this as 2.22222 dot dot dot, take away just x, which was 0.2 recurring, 0.22222 dot dot dot. Okay, and we're going to work this out. So 2 take away 2, hopefully you can see that all of these are just going to be 0. 2 take away 2 is 0, and that happens for all infinity twos. All of these will just be 0, except when we get to the decimal, we've got 2 take away 0, which is 2. So 9x is equal to 2.00000, which is just 2. So 9x equals 2. From here we can figure out what x was. But wait a minute, we already know what x is, 0.2 recurring. But if we just divide both sides by 9, 2 divided by 9, we can write as a fraction. And that is our recurring decimal as a fraction, 2/9. So it kind of circles back to what x was originally, but instead this time we've got it as a fraction. Because we know that 9x is equal to 2, so 1x must be 2 over 9 as a fraction. Now, the reason we found 10x was so that these digits lined up nicely. If we found the wrong number of x, then we wouldn't get rid of these digits. They wouldn't all cancel out to make 2 and then infinity zeros. So let's see what happens if we use a slightly more complicated example. Let's say we want the number 0.523 recurring, and it's the 2, 3 that are recurring. So really this is 0.5232323232323, and 2, 3 just keeps going on forever. There's infinity 2 3s, but there is a 0.5 at the start. Alright, so we're going to find out what this very strange decimal is as a fraction. So first things first, we call it x. We say x equals the decimal, and then instead of finding 10x, we're going to have to find 100x because there's 2 digits in the pattern, so we want 2 zeros after our 1, so we're going to find 100x. Now remember, we can just move the decimal place along, so since we're timesing it by 100, we just move it 2 places, so it's going to be 52.323232323. 52, because the pattern is 2 3 recurring and it starts from here, so it will go on like that. So 52.3 2 3 etc. 3 2 recurring. Now it looks like it's switched round, but there's 5 setting it off there after the decimal, so this all works out, it's all fine. Alright, so we found x equals 0.523 recurring, we found 100x, that's just 100 of those. Now we do 100x take away 1x, which is 99x, and we're going to work that out. So 100x, that's 52.32323 blah 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 blah, take away 1x, which is 0.52323 blah 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 blah. Well, 3 take away 3 is 0, 2 take away 2 is 0. You see how those line up? If we did 10x, we'd have 2 take away 3 and 3 take away 2, and it would be a bit awkward, and it would still be a recurring decimal. So 3 take away 3 is 0, 2 take away 2 is 0, and then 3 take away 5, we have to borrow 10, so we'll make that 13, and the 2 drops down to a 1. 13 take away 5 is 8. And then 51 take away 0 is just 51, so we have 51.80000. That's 99x, 51.8. Then we can divide both sides by 99, so x is equal to 51.8 over 99. And then that's x, the original value, as a fraction. It's got a decimal in it, which is a bit awkward. We can sort that out, we can change that. But it is now as a fraction. We can multiply the numerator and the denominator by 10. That gets rid of the decimal, so we'll have 518 over 99 times 10, which is 990. From there we can simplify it, and that gives us our value x, our decimal 0.532 recurring, 23 recurring, sorry, as a fraction, 518 over 990. From there it might not be too difficult to simplify. So we could do half the top and the bottom because they're both even. So half of 518 is 259, and then half of 990 is 495. And I think that might be as simple as it goes. Off the top of my head, not certain, but that looks like it might be as simplified as that can be. So that is 0.523 recurring as a fraction, 259 495.